Hello everyone. Today I am going to start the numerical on the root locus, which is a topic from the stability, right? So in this lecture today I am going to talk about the numericals. In previous lecture I had discussed about the root locus. What are the steps of root locus? How can we solve, right? In this lecture I am solving the numericals on the root locus and what is the effect of adding a pole or a zero, right, to an open loop transfer function, right? And what are the advantages of the root locus? Okay, so this is the numerical. Here I have to sketch the root locus for the system which is having GSHS open loop transfer function GSHS equals to k upon s into s square plus 2s plus 2. So the step one for solving the root locus is to find out the number of poles, number of zeros, and the number of branches of the root locus. So here if you see, there are 3 poles in this denominator. From the numerator we will get the number of poles, and these poles lies on s is equals to 0 and s is equals to -1 plus minus j. Okay, and there is no 0 in this question. And now the number of branches of the root locus will be equals to the number of poles. As we have the in this step we have, if p is greater than z, then the number of root locus branches of root locus will be equals to p, and if z is greater than p, then the branches of the root locus will be equal to the number of zeros. So here p is greater than, since p is greater than z, so the branches of the root locus will be equals to 3, right, and represents the branches of the root locus. Okay, so there are 3 branches. So the 3 branches of the root locus will originate from the poles of the open loop transfer function and will terminate at k is equals to infinity, right? So now let me first of all plot the number of poles and zeros. Okay, here I'm only right, I'm drawing the root locus graph step by step. Okay, so number of poles are 3. One is lying at s is equals to 0, one is lying at -1 pe +1. This is imaginary axis, this is imaginary axis, this is the real axis, imaginary axis, and this is -1. So one pole is lying here and one pole is lying. So you can observe in this question there are imaginary poles, so we have to find out the angle of departure as well. Okay, so coming to the next step number 2, to find out the region of root locus. So the way to find out the region of root locus, I am considering a point here. Let's say this is the point P. While looking towards the right from the point P, if the sum of the number of poles and zeros is odd, then that region will be the region of root locus. So here there is only one pole, right? So this is the region for the root locus. Root locus will lie in this region. Okay, region of root locus. Okay, only one point is considered here, और हम देखेंगे कि, and the another step is कि step 3 में we know that the root locus is symmetrical about the real axis. हमें ये भी पता है, ठीक है, and region of root locus हमने find out किया in step 3 कि our root locus will lie in the entire left half region. Okay, now step 4, to find out the asymptotes. Okay, so the formula for finding this asymptote will be theta will be equals to 2q plus 1 into 180 degree upon p minus z, right, where q will be equals to 0, 1 up to p minus z minus 1. So in this case q will be equals to p minus z is 3 and minus 1 is 2. So 0, 1, 2. So basically there are 3 asymptotes for this question. So theta 1 will be equals to, when I'm putting q is equals to 0 and p minus z is 3 here. So this is 3 by 180 is 60 degree. Theta 2 will be equals to, again this is 2, 3 and this is 3. This is 180 degree and theta 3 will come out to be, this is 3 and this is 5 now. 3, 6, 6 5s are 30. So this is 300. Now how to draw these asymptotes on the root locus? So with the help of centroid, we'll be able to plot the asymptotes. So step number 5 will be centroid. To find out the centroid. Centroid, the formula for the, see, these asymptotes are the guiding lines for the branches of the root locus, right? And with the help of this centroid, we'll be able to draw the asymptotes on the root locus. The formula for the centroid will be summation of real part of poles minus summation of real part of zeros upon p minus z. So this will be summation. Real part of poles is only -1, -2, right? And there is no zeros, and p minus z is 3. Okay. So -2 by 3 is the centroid. So it comes out to be -0.66. Okay. Okay. So let me draw the centroid from minus. This is -0.66. Let us assume. So this is the centroid. Okay. And now from centroid, I am drawing the 3 asymptotes. This is, let's say, 60 degree. Okay. Then another one is 180 degree. This is 180 degree. And then 300, 270. And this is 300. This is the 300. 300. Okay. Because these are the asymptotes. Okay. Now the next point is to find out the breakaway point. So how to find out the breakaway point? Breakaway point can be found out with the help of the characteristic equation, which is 1 plus GSHS is equals to 0. So what is GSHS? K upon S into S square plus 2S. So 1 plus K upon S into S square plus 2S plus 2. Am I right? 2S plus 2. Okay. Is equals to 0. So यहाँ से क्या आ जाएगा ये S cube plus 2S square plus 2S. Okay, S cube plus 2S square plus 2S plus K is equals to 0. Now we have to put, to get this equation in terms of K will be equals to minus of S cube minus 2S square minus 2S. Now to find out the breakaway point, we have to go for dk by ds equals to 0. So this will give us minus of 3s square minus of 4s minus 2 will be equals to 0. While solving this, okay, I'll get the two values of s, okay, from this equation. This is plus, na? K is equals to everything. Sorry, this will be plus. Am I right? And this is again plus. So 3s square plus 4s plus 2, right? So from this equation, the two values of the breakaway points are, the two roots of the are minus k 0.06 plus minus j into 0.47, right? See, these are the two values. So since we know that the breakaway point lies only on the real axis, so this is not the valid breakaway point. This is invalid breakaway point, right? If I'll get the value of s in terms of real part, then that value should be kept in the equation of k, and from the equation of k, when I'll get the value of k as positive, that root will be the exact breakaway point. So in this case, there is no valid breakaway point since these are lying on the imaginary axis. So next step is to where this so basically the three branches of root locus originate from this 0. Okay, from one is originating from here and one is originating from here, right? And one is originating from this 0. So since there is no breakaway point, I have to check where these branches are originating and where these are leaving. So next step is intersection with the imaginary axis. Intersection with the imaginary axis. Okay, so this is why we get from the by applying the Rao theorem, and Rao theorem will be applied on 1 plus GSHS equals to 0. And what is the equation I am getting? SQ, that is SQ plus 2S square plus 2S plus K. SQ plus 2S square plus 2S plus K इक्वल्स टू 0. तो यहाँ से राहु तेरे क्या बन जाएगा? एस क्यूब, ये हो गया 2 एस की पावर 1 एस की पावर 0, तो ये हो गया 1 2 2 k and 2 to the 4 minus k upon 2, and this is nothing. Okay, and this into this minus this upon this again k. So from here I can see the auxiliary equation will be, first of all, the marginal value of k will be 4 minus k upon 2 must be greater than 0. So from here the marginal value of k is equals to 4. When I am putting this value 4 in this, I'll get, this is the auxiliary equation, 2s square plus k is the auxiliary equation, and when I am putting the value of k here, so 2s square plus 4 equals to 0. Okay. After putting this value, I am getting the two values of s from here, which will decide the point on the imaginary axis. So this is plus minus root 2 I. So this is the point where the branches of root locus are cutting at the imaginary axis. Now the three branches which are originating, the one will be terminating here. One will be starting. The one branch will originate from this pole and will terminate towards this, where k is equals to infinity. Another branch will originate from here. So first of all, I have to find out the angle of departure, right? So for angle of departure, I am drawing the diagram once again, only for the poles. One of the pole is lying at origin and one of the pole is lying at minus j. This is plus j and this point is minus 1. So to find out the angle of departure, I have to see what are the angles other poles are drawing. So angle of departure, the formula for angle of departure, phi d will be equals to phi minus phi p minus phi z. Phi minus phi p minus phi z. एक मिनट, sorry, phi p minus phi z नहीं है, 180 degree minus phi p minus phi z. So phi p is the contribution of all the poles on this particular pole, right? And the phi z is the contribution of all the zeros made on this particular pole, right? So phi p will be equals to, this pole is contributing 90 degree directly to this pole, right? So phi p will be equals to, and phi z here is 0. कोई 0 ही नहीं है हमारे क्वेश्चन में. Now phi p मुझे find out करना है. This is making 90 degree, right? Now I have to find out this. Let's say this is phi p1, right? Now phi p1 can be find out if I find this angle as theta. So phi p1 will be 180 minus theta. Now how to find out this theta? Theta will be, from here, this theta will be equals to tan inverse, perpendicular is 1 and base is also 1. So it come out, theta come out to be 45 degree, right? So this phi p will be 90 degree plus phi p1, right? And phi p1 is what? 180 degree minus theta, right? And what is theta? Theta is this. So it has come out to be 135 degree. This 5p1, right? तो 135 डिग्री जब मैंने इसमें से सब्ट्रैक्ट किया, सॉरी इसमें 5p ऐड किया, 5p विल बी 135 प्लस 90, 225 डिग्री. Am I right? This is 225 ना? हाँ, 225 degree is 5p. Now putting the value, now 5d will be equals to 180 degree minus 225 is coming out to be minus के 45 degree. Since this is 5d1, जितना पोल इसने minus 45 degree बनाया, that means this will make plus 45 degree. So 5d2 will be, you can directly write as our root locus is symmetrical about the root real axis. So I can directly write 5d2 will make 45 degree. So this make 45 degree and will move towards here. This will make plus 45 and will move towards here. ठीक है, ये कटिंग क्या हो रही है वो हम पॉइंट्स फाइंड आउट कर चुके हैं. सी प्लस माइनस 2 रूट आई पे, तो ये मेरा कहीं आ रहा होगा 1.4, ये जो कटिंग हो रही है 1.414 आई पे, और ये भी यहाँ से कहीं कटिंग हो रही है, ये 1.414 root 2. Okay ना. So you can see this is the graph. Here this is the one pole, this is the another pole, whereas this is the another pole and this is the third pole. ठीक है, और this is 0.67 is the centroid आया था, और यहाँ से मैंने एक 60 डिग्री का बनाया. ठीक है, ये 180 डिग्री का था हमारा, और ये हमारा तीसरा आया 300 डिग्री का, राइट. और ये देखिए यहाँ से प्लस 45 डिग्री का एंगल बन रहा है, ये 45 डिग्री से ऐसे गया और ये माइनस 45 डिग्री से ऐसे गया इन द डायरेक्शन ऑफ एसिम्प्टोट. और ये पॉइंट क्या आया हमारा यहाँ पे, कटिंग पॉइंट विद द इमेजिनरी एक्सिस, माइनस के 1.414 प्लस के 1.414. सो दिस इज द एक्चुअल ग्राफ ऑफ द रूट लोकस, राइट. सो अगर k is equals to, at k is equals to 4, where marginal value of the core, right, 4. So the dominant roots are on the imaginary axis and the system is said to be the marginally stable, right. And if k is greater than 4, then the roots will shift in the right half of S plane and system will become unstable in nature. While if k lies between 0 to 4, then roots will shift in the left half of S plane and system will be absolutely stable in nature. I hope this question will be clear to you. Okay. So next, coming to the effect of adding poles and zeros to the open loop transfer function. So for that, for explaining the effect of addition of poles, I am considering the GSHS is equals to k upon s into s plus 2. So there are basically two poles in this open loop transfer function. One is lying at s is equals to 0 and another one is at s is equals to minus 2. So when after solving this term, open loop transfer function, getting the root locus like this. Okay, this is the breakaway point which is lying at minus 1. Now I am adding a pole at s is equals to minus 4. Now my root locus will become like this. You can see the root locus is, the branches of root locus are moving in the right half of the S plane, right? Right. So see, addition of pole in the left half, system is totally stable, right? But after addition of pole in the left half, the two branches of root locus will move towards the right half of S plane. So up to this value, the system will be stable. But after this value of k, the system become unstable and oscillatory in nature if I'll add more values. Now, if I'll add s is equals to minus 6 also in this transfer function, see. So you can see that the new breaking point will be, breakaway point will shift towards the right half of S plane, right? Now, this system is, here you can see that the breakaway point is also shifted. System becomes more unstable in this type, right? So, and this is the actually root locus. Okay. So, what are the effects of adding a pole to the root locus? The root locus will shift towards the imaginary axis, right? So the stability of the system will relatively decreases. right? And the system will become more oscillatory in nature. And the operating range of K for the stability of the system will be decreasing, right? Now, what is the effect of adding 0? The effect of adding 0 is totally opposite to the effect of adding poles to the system, right? If I am taking the same transfer function, open loop transfer function, where GSHS is equals to K upon S into S plus 2, right? If I'm adding here, this is the root locus. See, one of the pole is lying as S is equals to 0, another pole is lying at S is equals to minus 2. The value, the nature of root locus is this, right? Now, if I'm adding another 0 at S is equals to minus 4. So you can see the root nature, this is S is equals to minus 4. I am adding this 0 in this system. So the nature of the root locus will shift towards the left. The root locus will shifting towards the left, while in case of adding the poles, it is shifting towards the right, right? So the system will become relatively stable as we compare the previous case, right? Now again, I am adding one more 0 at S is equals to minus 6. You can see the new breakaway point will be this. It is shifted to the, again, left half of the S plane. This is the previous case, right? And this is this new case where I have added S is equals to minus 6 at the 0. So in this case, breakaway point is again shifting towards the left of the S plane. So the stability of the system will relatively increases, right? So we go on adding to the left. While we go on adding zeros to the left, the resultant root loci will shift towards the left half of S plane, and the relative stability of the system will get better, will get improved, right? So these are the effects of adding zeros on the system, that the root locus will shift towards the left half of the S plane, right? It will indicating the relative stability of the system will increase, and the system will become less oscillatory in nature, and the range of operating values of K for the system stability will increases, right? Now, what are the advantages of the root locus? So basically, root locus technique is more advantageous as it gives the following information. The absolute stability of the system can be predicted from the location of the roots of the S plane, right? Limiting range of values of the system gain K can be decided for absolute stability of the system. And the marginal value of the system gain K, which make it the system marginally stable, can be determined, and the corresponding value of the frequency of oscillations can also be determined from the intersection of root locus with the imaginary axis. By using the root locus, the value of system gain K for any point on the root locus can be determined by using this magnitude condition, right? And for a particular damping ratio of the system, gain K can be determined, which help us to design the system more accurately, right? Root locus help us in deciding the stability of the control system with the delay of the time, right? Gain margin of the system can be determined easily with the help of root locus. Phase margin again can be determined with the help of root locus, and relative stability about a particular value of S is equals to minus sigma can be determined with the help of the root locus. And moreover, the settling time, the information about the settling time of the system we can obtain from the root locus. So these are the advantages of the root locus. Thank you.